as we hurtle headlong into the digital age. Pause to ponder just how far we've come. The 80s generation had no .com, no digital. The future they imagine has been transformed by a technology revolution. My, how we've changed. Welcome to the short history of the modern world, charting the good and bad of a quarter-century of innovation. This is Stop Rewind. Ah, those magnificent men in their flying machines. Over 100 years of proving mankind can cast off the shackles of Earth with mixed success. Ouch! But what turned these analog antics into digital dogfighters was war. The world wars of the 20th century taught military strategists a thing or two about the advantages of a good fleet of aircraft. By the Cold War, it was game on to build planes that could go further, faster, and higher, or risk one serious aerial butt-kicking. In fact, jet aircraft, high-altitude flight, and supersonic speed owe their origins to aircraft developed with the military. Like the Bell X-1, it broke the sound barrier in 1947, paving the way for warbirds to scoot from cloud to cloud in the blink of an eye. Even commercial aircraft had their time in the supersonic spotlight. Unfortunately, all the Concorde learned was you have to be fast and sleek, which translates into expensive fares. The supersonic lessons learned by the military only created 25 years of Concorde excess, retired in 2003. Meanwhile, the military had kept on developing planes during the Cold War that could beat their opponents. Planes like the American-built SR-71 Blackbird. It could fly at more than 3 times the speed of sound. That's New York to London in 1 hour, 55 minutes. Allowing it to outrun the thousands of Soviet missiles launched at it as it flew over Russia, performing its main task of photographing military installations. Military aviation wasn't all about cool-looking planes, though. It was the technology inside the planes that could give a Top Gun the edge. GPS, Global Positioning System, is now so common you can get it in your phone. U.S. military have been playing with the idea ever since they heard the Russian Sputnik satellite beep at them. But it wasn't until 1983 when the Russians shot down a Korean passenger jet that had strayed into its airspace that the world realized GPS may be a little more handy than a navigational tool for military jets only. By replacing the complicated charting on paper maps that pilots used to do, science took human error out of the equation. Good to know next time you're flying close to restricted airspace. GPS and similar computer-based technologies may have made flying safer, but all those gee-whiz electronics created problems of their own. Signals between satellite, pilot, and ground crew can interfere with a plane's own control systems. That's why you're not allowed to use your mobile phone when a plane takes off. The Germans took the risk so seriously, they conducted elaborate tests to bombard planes with electronic signals. Take one plane, hoist it up a tower, and then switch on the transmitter. It all appears very low-tech, but future-proofing these planes from any high-tech interference provided lessons that commercial airlines could learn from. Flight was becoming less a luxury of the upper class and more a necessity of the tourist class. Lighter, composite materials and better avionics created bigger, better passenger aircraft. Until someone remembered that planes fly close to clouds. Clouds contain lightning, and lightning turns some composite materials into toast. A problem the older metal materials didn't have an issue with. As you can see in this test by NASA and the aptly named Lightning Technologies Incorporated, a composite sheet is obliterated by an artificial lightning strike. Add some aluminum to the composite material, and lightning does no serious damage. Ladies and gentlemen, this is now a non-smoking flight. It's experiments like these throughout the history of aviation that have allowed air travel to progress safely. While it's good to know the guys in the labs are making flying safe, often the lines between slapstick and science can be mighty thin. This experiment to test airline seating looks like a school bully's ultimate fantasy. And it just gets weirder. Like these dead chickens being blasted at a helicopter windscreen. Why? Because birds can be a plane's worst enemy. In fact, a half-kilo bird can hit a plane flying 650 kilometers an hour with a force of 7 tons. Lexan windscreens were developed, and as far as our records show, despite the reputation of airline food, no passenger has ever died from chicken. Also noteworthy, there's been billions of dollars spent trying to prevent aviation disasters over the past 50 years. From improved seating through to an idea to put every airline seat inside its own fireproof, crash-worthy pod. And this design even had an airbag, a very slow airbag. Despite being strong enough to resist a 30G crash, it never did take off. These seats would have meant a reduction in seating capacity and revenue on a normal jet by 28%. Let alone the sheer get-me-the-hell-out-of-here effect of spending a 12-hour flight in a box the size of a kennel. A more immediate solution to airline safety was this, the fire spear, designed to get water to where it's needed during a fire. As an external fire on a plane can spread to inside the cabin within 90 seconds. So there's no time to lose when extinguishing any cabin fire. But what about the pilot? Well, this invention, the EVAS, Emergency Vision Assurance System, is an inflatable plastic balloon that creates a smoke-free zone between the pilot's eyes and the dashboard. Simple and effective, the airline industry was becoming adept at creating solutions for every problem that may affect safety. Over 15 years later, the EVAS is still being used by major aviation companies. In fact, it seems nothing was out of order when it came to keeping planes from running headfirst into the ground. Take the pop-off chute, a parachute for a light plane, no less. This chute has since saved over 242 lives in various aviation failures, and as of 2009, is still in production. Why not use this system with commercial jets then? Well, to float a 747 safely to Earth would require 21 chutes, each the size of a football field. Speaking of big, if there's a will and a large amount of cash, you can get just about anything airborne. The Airbus Beluga is the plane to do it. It's ugly as hell and looks like it would have trouble just moving, let alone flying. While big was the theme for commercial aircraft, a cottage industry of aircraft enthusiasts was heading in a completely different direction. They were going small. Super small. One person small. They're called ultralights, and they became a serious pastime back in the 80s. Planes like this Vampire cost as little as $20,000 in 1989. Some were even designed to fly and swim, like the Italian Lomac Trike, which flew the length of the Nile in Egypt. While the rest of the world concentrated on super sleek and super fast, the Russians had other ideas. This extraordinary machine is the Ekranoplane, nicknamed the Caspian Sea Monster. It took flying to a whole new level. In fact, a whole new low level. This 550-ton Leviathan flies using ground effect, just like a pelican, riding on a high-pressure cushion of air squashed between the wing and the water. Unfortunately, the Caspian Sea Monster crashed and sank in the 1980s. But the ground effect dream lived on. And in the early 90s, this vehicle hit sunny Florida. This is the Airfiche, designed in Germany, but perfect for the Caribbean. Without having the drag of water like a boat, nor the fuel-burning power needed to get altitude like a plane, the Airfiche can run very efficiently, very fast, with a range of 300 kilometers. It's also classified as a boat by the U.S. Coast Guard, despite the handling similarities to a plane. While traveling faster than any other marine craft and running more efficiently than a higher altitude plane, ground effect vehicles still haven't found their niche. Perhaps in another 25 years. But here's some flights of fancy you'll probably never see again. This one's called the Rubber Bandit, a scale model rubber band powered plane that was meant to carry a pilot. Moving from rubber bands to reptiles, the flying fossil is one wild idea that did earn its wings. The theory went that if dinosaurs with minuscule brains can get off the ground, then we superior humans should be able to copy them. And we did. A fun exercise? Sure. But if anyone ever offers you a flight in a flapping aircraft, just say no. For graceful, effortless flying, nothing beats an airship. In the 1980s, it looked like they were going to make a comeback. This is the Skyship 600, smoothly powered by 2 Porsche engines. It was just another example of how every few years, someone hails the return of the airship. Let's face it, with the exception of a few specialized applications, like this one, bouncing electrical signals off the Earth in search for precious metals, airships are all grace and no pace. So they were no competition for high-speed jets. But airships do have a place, like gliding effortlessly and, more importantly, silently. These rainforest research stations, perched high in the treetops of South America, demand quiet for their animal inhabitants and easy access for scientists. So the airship is ideal. The popularity of airships 25 years ago was so great, there were even prototypes for commuter-style craft. Developed by American inventor Steve Garner, this was one of the first ground-up designs for an airship since World War II, and it successfully flew. But the inability of the public to see the blimp as a replacement for the car meant the personal blimp never became anything more than an aviation sideline. Heavy industry also flirted with the airship. Enter the Helistat. Designed to carry massive payloads, this 100-meter-long monster was the biggest flying structure ever built. Inflated by 1 million cubic feet of helium gas, it was meant to be flown with the help of 4 H-34 Sikorsky helicopters. But it all came to naught. In a test flight in 1986, one of the helicopters broke free from the frame and crashed, killing the pilot. There's been no further development with the Helistat since. One airship idea that did fly was the Stingray inflatable plane. The Stingray worked on the principle of using the large area but light weight of a balloon to provide the lift for an ultra-light aircraft. The Stingray's big advantage was that it could be easily deflated and stored when not in use. This plane's inspiration came from the hollow, lightweight bones of birds, proving once again that given time and natural selection, nature eventually gets things right. And from our feathered friends, we also came up with the idea of immediate takeoff. Using a catapult to launch ultralights into the air, much the same way a bird's legs launch it into the air. Shame there's not a big market for getting ultralights airborne. If you can get a whole platoon of military troops airborne ASAP, just like a helicopter, then fly them through the sky at twice the speed of a helicopter, you've got a product. And that's what this is, the tilt-rotor aircraft. They've been slowly evolving over the past 50 years, and the V-22 Osprey is the first production model, hitting the battlefields of Iraq with the U.S. Marines in 2007. It flies faster than a helicopter, because once a chopper's blades start spinning at high speed, the resulting turbulence and vibration risk crashing the aircraft. But if those blades are only used to lift the aircraft into the air at low speed, after which the wings take over, allowing for high-speed travel, then you have a more stable, faster vertical takeoff and landing aircraft. For real groundbreaking inventions, creations that fly above and beyond any current expectations, there is one designer who borders on genius. Burt Rutan. Born in 1943, Rutan was designing planes at age 8 and piloted his first solo flight at 16. He designs planes that are almost organic in their shape and structure, with engines at the rear, smooth curves, and catamaran-like bodies. But they're based on some practical engineering. Most metal construction wings are quite fragile. You can see Rutan jump straight through one. The composite materials he helped pioneer are stronger and can be shaped into more aerodynamic forms, like this long-ease small plane. But the plane that really announced Rutan as a world-class aviation innovator could fly further than any aircraft ever made. Over 40,000 kilometers to be exact, non-stop for 9 days on one tank of gas. Known as the Rutan Voyager, this was the first ever plane to fly around the world. It was flown by his brother Dick Rutan and Dick's partner, Gina Yeager. At takeoff, the Voyager was carrying 4 tons of fuel, a huge volume considering the plane itself weighed less than half a ton. But they made it.
Who said I could get in an airplane and fly nonstop around the world? But the feeling is just that much better when you do it. You get a real warm glow about having done something that everybody said you couldn't do.
Rutan didn't stop there, though. In the early 90s, he designed a prop-driven plane known as the Pond Racer, capable of flying at 640 kilometers an hour. Unfortunately, before it broke any records, the Pond Racer crashed, killing pilot Rick Bricker. Tragic, but Rutan soldiered on, continuing to design and build planes such as the Proteus, a classic Rutan composite construction with an unorthodox wing configuration and engine placement. Able to fly almost 20 kilometers up, and for periods as long as 18 hours, the Proteus was designed to fly as a high-altitude communications vehicle. It would hover above a specific location and transmit telecommunications signals in much the same way a satellite does, without the excessive cost and long-term commitment of a satellite. This has now been eclipsed by its current usage by NASA and Northrop Grumman as a scientific platform for high-altitude experiments. It was also a stepping stone for Rutan's development of the first-ever privately built, reusable space vehicle.
The safest way to fly in the atmosphere is with a turbofan airplane. The most dangerous place to fly a rocket is at sea level. So if we take a rocket almost out of the atmosphere and then launch it, we have an optimized way to have very low-cost access to space.
Simple, intelligent, practical. Through his futuristic designs, Rutan paved the way for mainstream space travel. And then made it a reality in a Rutan-designed spaceship, which will be the world's first ever regular space tourism vehicle. Launched from a mothership and flying as part of the Virgin Galactic venture, you can now buy your ticket and line up to fly into space, leaving the runway in a plane and landing just like a plane, but spending real time in the peaceful black awe that is space. The first step in a giant leap to how you will one day fly well beyond anything the Wright brothers could ever have imagined.